Hi everyone, good morning. Today we will learn an interesting algorithm, that is Diffie-Hellman key exchange algorithm. Cryptography is a technique which is used to convey a message in secret. There are two schemes of cryptography. One is called symmetric key cryptography, another one is asymmetric key cryptography. In secret key cryptography, the sender and the receiver uses the single key, same key for encryption as well as decryption. So before transferring a message, a key must be shared between the sender and the receiver in secret. Diffie-Hellman algorithm is used to generate and share the secret key between the sender and the receiver. This Diffie-Hellman key exchange algorithm is a public key algorithm which enables the two users to establish a secret key between them. In this algorithm, the security is assured by a secret key which is generated from a prime number and its primitive root. Now let us see what is primitive root, how it helps to generate the secret key. The primitive root of a prime number is 1, whose powers modulo p generate all the integers from 1 to p minus 1. That is, if a is a primitive root of a prime number p, then a power 1 mod p, a power 2 mod p, a power 3 mod p, etc. up to a power p minus 1 mod p will generate distinct and consists of integers from 1 through p minus 1 in some permutation. That is, if we write b is equal to a per I mod p, where I ranges from 1 to p minus 1, then b is also an integer which ranges from 1 to p minus 1 with some permutation. It is relatively very easy to calculate the value of b by choosing a value for I which is from 1 to p minus 1. Then by using the formula b equal to a power I mod p, we can easily calculate the value of b. But the exponent I is referred to as the discrete algorithm of b, which is written as I is equal to d, that is discrete logarithm of ap discrete logarithm. For large prime numbers, the task is considered to be infeasible. In this algorithm, I is used as a secret key. Now let us represent the pictorially the Diffie-Hellman algorithm. Here, this Diffie-Hellman algorithm is a public key algorithm. That means some values are made public to both sender and receiver and to everybody. So let us consider Alice as a sender and Bob as a receiver, and they have a common paint color as yellow, and that is common to everyone. Everybody knows the color of the paint. So yellow is public. And Alice will choose a secret key that is red, and he mix that color with this yellow and he'll obtain a new color. Okay, and similarly Bob also choose some other color as his private color, and he mixed that color with the same yellow color and he arrive at a new color. Now Bob will exchange this new color to Alice, and Alice will exchange that color to Bob. Now what Alice will do is Alice will mix his own secret color with the mixture color received from Bob, and he will obtain a new color. And this is the combination of yellow, red, and the secret color of Bob. Similarly, Bob also mixed his own private color, secret color, with the mixture received from Alice, and he also arrived at the same color, because this is a combination of yellow secret color of Bob and the secret color of Alice. So both arrive at the same color. So this is the common key. So without explicitly exchanging the secret key, but both arrive at the same color. So this algorithm or this concept is used in Diffie-Hellman algorithm. So in this algorithm, we are going to choose two values as public values. One is the prime number, any prime number. Let us consider Q. Q is the prime number. And alpha is nothing but the primitive root of the prime number Q. So Q and alpha are public keys. Everybody knows the value of Q and alpha. And A will select a random integer XA as his private key, where X is less than Q. That is, he can choose any value less than the prime number Q. So XA is the prime secret key of Alice. Now he will calculate the value of YA. YA is equal to alpha raised to the power of his secret key XA mod Q. So now alpha and Q are common to everybody. Everyone knows that values. Now A will choose a secret key as XA, where XA is less than Q, and calculate YA. YA is equal to alpha raised to the power of XA mod Q. Similarly, B also choose another value XB, is also less than Q, and calculate another value YB, that is equal to alpha power XB mod Q. XB is the secret key of B. Now, person A, that is A, will exchange the key YA or share the key YA to B, and B will share the value YB to A. Okay, now each side keeps X value, that is XA and XB as secret, and share the values YA and YB to other side. Now user A compute the key value as K is equal to YB, that is YB is the value received from B. So YB raised to the power of XA. XA is the secret key of A. So YB raised to the power of XA mod Q. Similarly, B also compute the key value as K. K is equal to YA. YA is nothing but the value received from A raised to the power of his own secret key XB mod Q. Now, this calculation will produce same value as K will be same for both. Okay. So the calculation will produce identical result such as K is equal to YB raised to the power of A. This is the value calculated by A. YB is the value received from B. YB raised to the power of XA mod Q. And we can write what is YB. YB is nothing but alpha power XB mod Q power XA mod Q. And if we take the common terms outside, then he will arrive at the value alpha power XB XA mod Q. Then if we take XB outside, XA XU mod B, and we bring the mod Q inside. So it will be alpha raised to the power of XA mod Q X power XB mod Q. Now what is alpha raised to the power XA mod Q? That is something YA. YA raised to the power XB mod Q. So now this is nothing but the key, K value key calculated by XB. So we can move to the previous page. Okay. K, the value calculated by XA is K is equal to YB raised to the power of XA mod Q. And the value calculated by B is YA raised to the power of XB mod Q. And both are same. We start at this value and we end at this value. Here, in the equation. Okay. YB raised to the power of XA mod Q is equivalent to YA raised to the power of XB mod Q. So both sender A and the receiver B will arrive at the same key. So this key K can be used for encryption as well as for decryption. But they are not sharing the key K explicitly. They are sharing only the value of YA and YB. So now how the security here is, now consider a hacker who can observe the value of key exchange, wishes to determine the value of the key K. Because XA and XB are private, and adversary only has the following ingredients to work. He knows the value of Q and alpha, which are public, and YA is shared by A to B. So he may be able to hack this value of YA or YB. Okay, so he knows the value of Q, alpha, YA and YB. Using this value, is it possible to determine any one of the secret key, that is XA or XB? Okay, we all know that XA is equal to discrete logarithm of YA to the base alpha and Q, and XB is equal to discrete logarithm of YB alpha and Q to the base alpha and Q. So YB, XB YB, alpha and Q are known. Similarly, YA, alpha and Q are known to the hacker. But even though he knows all these values, it is very difficult to find the discrete logarithm of some particular value. So the adversary can then, if he arrive at the value of XB or XA, then he can easily calculate the secret key value K. But even then, the adversary knows the value of YA, alpha, Q, and YB. It is very difficult for him to calculate the value of the private key XA and XB through discrete logarithm. It is very difficult to calculate the discrete logarithm. So, the security lies in choosing the value of the secret key XA and XB. So, without sharing the key in secret, but the keys are exchanged between the two users. So this is the Diffie-Hellman algorithm, which helps to share the common key between both the users sender A and receiver B. So this key, secret key, is used for encryption, symmetric key cryptography, where the sender will encrypt the plain text into the ciphertext using an encryption algorithm using the key. The same key is used by the receiver B to transfer the ciphertext to plain text. That is again the original text. So thus Diffie-Hellman algorithm is used to share the common key between sender A and the receiver B without distributing it or sharing it explicitly. So the Diffie-Hellman algorithm is a famous algorithm to share the message in secret. Thank you.